Alright, so in this video we are going to be looking at variable and expression. First of all, what is a variable, or what are variables? Variables are symbols used to represent unspecified numbers or values, e.g. x, y, z are commonly used variables in algebra. What do I mean by that? For instance, if you have, say, 2x minus 3 is equal to 5. X in this particular equation is a variable. It's a variable because we are looking for that value such that when we multiply it by 2 and we subtract 3 from it, it would give us 5. So basically, variables are usually letters that represent unspecified numbers. So they normally represent numbers. They represent quantities, tangible. So if I solve this particular value now, I'll get the value that corresponds to this variable x here. So that is that. So that is that about that. Now let's look at expression. Most of the time, students do not understand the difference between equation and expression. What I've written here is an equation with a variable, but expression is basically a collection of numbers, variables, operation, and grouping of symbol. One thing you need to understand if you are watching this video is that expression is not introduced by equality sign. So if I want to write an expression, if I write 2x is an expression, is an algebraic expression that comprises of a variable and a coefficient, which is 2. If I write 2x minus 3, this is an algebraic expression. But whenever I write 2x minus 3 is equal to what? Something, it has become an equation. So what makes it an equation is the presence of this equality sign. Though this equality sign could also be an inequality sign. So when we get to that, I'm going to be explaining it. So that is the difference between variable and expression. So we are now going to be looking at different algebraic operations, the verbal phrase, and the algebraic expression. So let's look at that. So look at this. Here we have different algebraic operations, the verbal phrase that introduces them, and the algebraic expression. So for the algebraic operation addition, when you hear the word sum, the sum of 20 and a number n, this is a number n. What it means is what? 20 plus n. Basically, the word sum here is the result you get from addition. Alright, because n is a variable, so we can't write the result, so we have to present it as 20 plus n. Assuming we know the variable n, maybe it's 2, right? The algebraic result we are going to be having here will be what? 22. But this is an algebraic expression, that's why we don't have equality sign there. Then if you have the sum of a and b, that would be a plus b. Then we have 9 more than twice a number a. There is a number which is a. So when you say twice a number, that is 2 times what? A. And 9 is more than 8, that is what? Plus 9. So that is why we have 2a plus 9. Then in this case, we have a number m increased by 12. So meaning that m is a number, is a variable basically, because we don't know what corresponds to m. And when you increase it by 12, you have m plus 12. So for the subtraction operation, it follows the same logic with this. And the subtraction operation says that the difference between a and b, that will be a minus b, right? And the difference between x and 7, that is x minus 7, all right? Then 3 less than a number b, meaning that there is a number b and 3 is less than it, so that would be what? B minus 3. Then 3 times a number k decreased by 5, that would be what? 3 times a number k then decreased by 5. That decrease implies subtraction, so that's why we have 3 times k will give us 3k. Then we have the decrease by by 5. Then 9 minus a number n, that will be 9 minus n. So for multiplication, all of these are not exhaustive, we still have other further. So when we begin to apply them in question, we're going to be, so it also applies to multiplication. 11 times p to the third power. To the third power means p raised to the power of 3, right, times 11. So that will give us 11p raised to the power 3, also known as 11p cubed. Then the product of minus 2 and a number n, right? That will be minus 2 times, and you see that I put equality sign here, right? So that will give us minus 2n, though it doesn't change the fact that this is still an expression, right? Now the word product basically is the result. Let me quickly explain certain things. When you say sum is the result you get when you add certain set of numbers together. When you say difference, that's the result you get when you subtract numbers of variables. And when you say product, is the result of multiplication. Let me take it again. Sum is the result of addition, difference is the result of subtraction, while product is the result of multiplication. Now when we get to division, we have what we call quotient. Okay, so this one says 2/3 of a number x, that is 2/3 multiplied by x, that will be 2/3x. Okay, then lastly, let's go to division. Let me scroll it up. So for division, n divided by 8 is n/8. Then the quotient of 15 and a number d. So when you see the word quotient, right, that is what the numerator of that particular variable or number, as it were. So before I proceed, I want to give a recall that that sum, right, is the result of what? Of addition. The result of addition. Then product, no, let's start with I talked about difference. Yeah, so difference is the result of multiplication. Okay, the result of multiplication, while product is the result. Pardon me, I made a mistake. Difference is the result of subtraction. Sorry for that, of subtraction. Okay, while product is the result of what? Multiplication. All right, so sum, when I say the sum of 2 and 4, the answer should be 6, not 2 plus 4, because I'm only interested in the result. Then the difference of 5 and 3, right, the answer should be what? 5 minus 3, which is what? 2. And the product of 2 and 5 will be what? 10. All right, I'm focusing on the result. All right, so that is that about that. Now, having gotten this understanding, these few stuffs I've put here, let's now look at an example that we can use in validating all this information. So let's look at this question. This question says, write an algebraic expression for each verbal expression. So for A, so let me put solution here. This is a straight to the point question. Do I need to? Okay. It says that 10 less than 1/4 the cube of p. Now let me make something clear. When you see a problem like this, there are problems that you interpret from the first statement, there are some problems you interpret from the middle statement, there are problems you interpret from the last statement. So it is obvious that this one we have to interpret it from the last statement. It says 10 less than 1/4 the cube of p. So we need to know the cube of p. So cube of p is what? P raised to power what? 3. Then 1/4 of it, 1/4 the cube of p, that will be 1/4 times p cube. That will be what? 1/4 what? P cube. And we're told that 10 less than it. So if 10 is less than it, that will be what? Minus what? 10. So the answer to this is what? 1/4 p cube minus what? 10. So that is how. So you notice that we interpreted it from the last statement, then back to the first statement. Then for B, it says twice the difference between x and 16. The first thing is we need to know the difference between x and 16. So the difference in this case between x and 16 will now be what? X minus what? 16. Then twice the difference. So the twice will actually be what? 2 times x minus 16, and that will return what? 2 into bracket x minus 16. So this will give us 2 into bracket x minus 16. So this is twice the difference of x minus 16. Then let's move on to the C. So C in this case, it says that 4 times the sum of a number and 3. So the first thing we need to know is we need the sum of a number and 3. Sum of a number and 3 will now be, let the number be n. So that will be what? N plus what? 3. Then that's a 4 times. So 4 times the sum of that number, that will be what? 4 times what? N plus 3. And that will give us what? 4 into bracket n plus what? 3. So that is that about that. So this one is what? 4 into bracket n plus what? 3. Then lastly, the question D. Question D says 4 times a number increased by 3. 4 times a number. So we can say let the number right be what? Be n. So 4 times the number, that will be so 4 times the what? The number basically will be what? 4 times n, which is what? 4n. Now increase by 3. Now you notice that this one was, interpreted from the beginning, not from the last, because that's the nature of the question. So increased by 3, increased by what? 3. That will give us what? 4n plus what? 3. So this one will definitely give us what? 4n plus what? 3. So that is how you write an algebraic expression for verbal statements. So we are going to be looking at every other application in the next example. Thank you for watching. If you have any comment, please you can send me a mail. I'll be looking forward to receiving your mail. See you in the next video. Bye bye.